Where the edge of the Arctic ice transitions to open water in the Beaufort Sea, north and west of Alaska, 2014 was a year of intense fieldwork for the Marginal Ice Zone Program.
Yes, it was absolutely a success. It was amazing.
Craig Lee of the University of Washington's Applied Physics Laboratory.
We have this amazing picture of the ocean, atmosphere, and ice going from the fully frozen period in March to the meltout and the breakup, right through to freeze out.
The data that make up this amazing picture will advance the main objectives of the MIZ project: to understand the physics that control sea ice breakup and melt in and around the ice edge, and develop new robotic networks for collecting observations in, under, and around sea ice.
We were doing things that had never been done before, large deployments of robotic platforms, maintaining a persistent presence with this large number of robots over the course of nearly half a year, really, when you count all the instruments that were out there. Almost all the instruments function pretty much flawlessly. Data return was fantastic, remote sensing was great. The collaborations were incredible. Everybody worked together well as a team.
An international team made up of scientists from more than a dozen organizations.
We had a very interesting year in terms of wave activity, meaning we had very little wave activity. It was surprisingly calm when we were up there in the Aeron, both when we were in the ice and when we were in the open water. There just wasn't much wind, and so there weren't very many surface waves.
We're in the Beaufort Sea, which is north of Prudhoe Bay, Alaska. We're about 150 nautical miles off of land, and we've been up in around the ice edge for a week now. We've been using some buoys to measure the waves and the ice and understand how waves are approaching the ice and breaking up the sea ice. And now, as it's October, it's the end of the warm season, and it's starting to get cold, and the ice is starting to refreeze. And we're looking at how the waves are interacting with the ice as that unfolds.
Jim's primary focus is the surface waves. He's made some fantastic measurements looking at the differences between surface wave activity outside of the ice and then surface activity, wave activity as he moves into the ice. And he sees huge attenuation as the waves enter the ice, so they die back very quickly.
Here at the ice edge, you can see a bunch of large ice floes that are moving up and down in the wave. And just downwave of these, you can see it's really clear of all of the high frequency waves. So those bigger flows are really scattering all of the high frequency components and really cleaning out that wave set. And only the lower frequency stuff propagates through. It makes this very beautiful wave.
We're sampling the ice edge, ice play as we call it, doing underway CTV, doing casts every 100 meters or so, 100 to 200 meters, with really high resolution, both along the ice edge and away from the ice edge. Seeing wonderful signals, great horizontal gradients.
The gliders actually did what they were supposed to do. The gliders went from open water through the marginal ice zone, deep into the ice and back again. They collected over 20 sections like that, expanding open water into the ice.
Craig Lee was based aboard a Korean icebreaker.
The cruise was a typical annual cruise by the Korean Polar Research Institute. They own and operate the icebreaker Aeron. In addition to the MIZ team, they had scientists there from a number of other different countries. A very active group from Japan, scientists from Russia, from India, various different parts of the world, all working on different aspects of Arctic science. Next is a long period of analysis. We're just starting to look at the data now. We see very strong fronts in temperature and salinity, so very strong changes, horizontal changes in ocean temperature and ocean salinity that are associated with the edge of the ice. Each person, each group holds a piece of the puzzle, but nobody holds the whole puzzle. So the trick is to put all those pieces together and decide what really happened out there this year. and it will take months and years to really develop an understanding of what we think we saw.
Science at work for you. This is APL, the Applied Physics Laboratory at the University of Washington in Seattle.